here we have to first square root both sides of this trig equation. It's sine of theta all squared equals a quarter. Don't forget, when you square root both sides of an equation, you do need a plus and minus, and if you miss that here, you lose marks because you'll lose possible solutions to the equation. Now, you split that up further and you write it, instead of one equation with a plus and minus, you simply write it as two separate equations and solve them separately for values of theta in this range. Shift sine of 0.5 is 30 degrees, and then for sine we can do 180 minus that to get a secondary solution. And if we look at the other equation, shift sine of minus 0.5 is minus 30 degrees. 180 minus that gives us 210 degrees, but we can generate another solution by adding 360 to this principal value here. Minus 30 plus 360 gives us 330 degrees. So there we have our four solutions. Okay, part 2, it's one of these awkward ones where it's tan of some function of the angle. And the easiest way to deal with these is to do a substitution. So I've decided to use x because we haven't used x anywhere else in this question. Let x be 3 phi. And then this whole problem now is to solve tan of x equals root 3. But it's not between 0 and 90, it'll be between 0 and 370, won't it? Because phi needs to be between 0 and 90, and therefore 3 phi would need to be between 0 and 270. So I've written it out like this. So you can kind of ignore everything now except this. We're solving tan x equals root 3 for values of x in this range. And once we've got all of those, we'll go back and work out what phi must be. So shift tan of root 3 gives us 60 degrees. We can add 180 to that to get a secondary solution. And then simply to get back to phi, we just need to divide both of those solutions for x by 3 to get 20 and 80. And a couple of things to do before you move on is first check that they are indeed both in this range, and yes they are. And secondly, just do tan of 3 times 20. Does it give you root 3? Yes, on the calculator I mean. And do the same with 80 degrees, and then you can just check that the answers you've written down do indeed solve the equation you've just tried to solve.